So this is the first part of the review. 1 through 3 is solving square roots. In order to solve square roots, the first thing we have to do is isolate the root. In number 1, it's already isolated, so we can begin solving. We begin solving by squaring both sides so that we can get rid of the root, because raising something to the second power and taking the square root undo each other. So on the left side, we're left with x minus 2. And on the right side, we have the quantity of 4 minus x squared. 4 minus x squared can be rewritten as 4 minus x times 4 minus x. So then we distribute out the right side, or FOIL, if you want to call it that, by doing 4 times 4, which is 16, 4 times negative x, which is negative 4x, negative x times 4, which once again is negative 4x, and negative x times negative x, which is positive x squared. Continuing on, we end up with x minus 2 is equal to, just rewriting this right side to go from highest power to lowest power, x squared minus 8x plus 16. Before we start trying to factor or solve the right side, we want to make sure the equation is set equal to 0. I'm going to subtract x and add 2 to both sides to set the equation equal to 0. So 0 is equal to x squared minus 9x plus 18. We have a couple different methods to solve this, but for this one I would use factoring because this equation factors nicely into x minus 6 times x minus 3. And since the equation is set equal to 0, we can use the zero product property to solve both of those factors for x. So from the factor of x minus 6, we get x equals 6. And from the factor of x minus 3, we get x is equal to 3. So to start off, we have two solutions, 3 and 6. But we're unsure of whether or not those are solutions quite yet because we haven't tested whether those work in the original equation. So we always have to check our work in this section. So we get the square root of 3 minus 2 is equal to 4 minus 3. So the square root of 1 is equal to 1. 1 is equal to 1, which is correct. So 3 is a real solution. Now let's try 6. Square root of 6 minus 2 is equal to 4 minus 6. Square root of 4 equals negative 2. 2 is equal to negative 2. That is a not true statement, which means that 6 is an extraneous solution. So the only solution number 1 has is x equals 3. For number 2, the equation is not set equal to the square root. We haven't isolated the square root in number 2. So the first step in number 2 is make sure that we isolate the square root. So we subtract 3 from both sides to isolate the square root. This way on the left side we're left with x minus 3, and on the right side we have the square root of x minus 1. To continue solving, once again we square both sides. On the right side we're left with x minus 1. Multiplying out x minus 3 times x minus 3, we get x squared minus 6x plus 9. That is equal to x minus 1. Once again, the equation is not set equal to 0, so before we start factoring or using quadratic formula, or completing the square, or solving by square roots, we want to isolate the equation and set that equal to 0. X squared minus 7x plus 10 equals 0. This equation once again factors nicely into x minus 5 times x minus 2. Setting both factors equal to 0, we end up with the solutions of x equals 5 and x equals 2. But once again, we're unsure as if both of those are solutions or if none of them are, or even if just one of them is. So we plug in 2 and 5 into the original equation to see if it works out. So 2 is equal to the square root of 2 minus 1 plus 3. Well, 2 is equal to square root of 1 plus 3. 2 equals 1 plus 3. 2 equals 4 is not a true statement, which means 2 is extraneous. And also checking whether 5 works. 5 equals the square root of 5 minus 1 plus 3. So 5 equals the square root of 4 plus 3. 5 equals 2 plus 3. 5 equals 5, which is true. So 5 is a real solution. So the only solution that 2 has is 5. Same process for the last question, number 3. Number 3, we're only working with one x in the equation. So all we have to do to start off is isolate the root and then get x by itself. So to start off, we add 1 to both sides, and we get 2 root x minus 1 is equal to 10. Dividing by 2, we end up with the square root of x minus 1 is equal to 5. Squaring both sides. Oops, 10 acted up. Squaring both sides, we get x minus 1 equals 25. X equals 26. Plugging it into the equation to check if that is a solution. 2 times the square root of 26 minus 1 minus 1 equals 9. 2 times the square root of 25 minus 1 equals 9. 2 times 5 minus 1 equals 9. 10 minus 1 equals 9. 9 equals 9, which means 26 is the only solution, and it is a real solution. The reason why we get extraneous solutions is because square roots are not full sideways parabolas. What I mean by that is that the graph of the square root of x, once the board clears, there we go, looks like this. And if you're intersecting with a linear function, you might only have one real point of intersection. But if you had the negative square root, that would create the second point of intersection. Because this non-existent negative square root occurs where that second point lands, that's why we have an extraneous solution. Because the extraneous solution is not on the real root, it's on the fake root.